welcome to today's Sofics video tutorial. Today's topic is diode triggered silicon controlled rectifiers, Dtscr for short. What is a Dtscr? This is basically a standalone SCR which is augmented by diodes placed externally to it, as shown here, and which are then used to trigger it. Why do we need Dtscrs? Well, this is mainly related to the fact that a standalone SCR is a rather limited ESD protection device since its properties are fixed. In the case of a Dtscr, it is possible to accurately control properties such as its triggering voltage, its holding voltage, and failure current. And so in this way, it is possible to design ESD protection circuits for various types of applications. Think about RF, IoT, or automotive applications by departing from the same basic principle. Now, how does a Dtscr achieve this accurate control of its parameters? Well, take for example the holding voltage, the triggering voltage. The triggering voltage can be controlled accurately by controlling the number of diodes which are included in diode triggering chain as shown here. Now, we note that there are two possibilities for triggering the SCR, that is either using trigger tap G1 or tap G2. So if we need N diodes in the triggering chain for triggering from G1 for a given trigger voltage, then we need N-1 diodes for triggering from G2. This is mainly related to the fact that the anode G2 junction sits within the N well, which is isolated from the P substrate, whereas we don't have the same situation for the G1 tap. The holding voltage can be controlled accurately by including diodes here in series with the anode, and finally the triggering voltage can be controlled accurately by varying the size of the Dtscr. So what are the main advantages of using a Dtscr? What are the main benefits of a Dtscr for an IC designer? Well, first of them is a lower triggering voltage. For a standalone SCR, typically the triggering voltage is determined by the breakdown of the intrinsic junction which exists between the G1 and G2 taps. Typically, this is for specific technology. This can be of the order of about 15 volts. Now, for a Dtscr, since the triggering is external, the number of diodes actually determines the triggering voltage, so we can make it to be as small as possible, say 1 volt, for example. A second advantage of a Dtscr is its speed of operation. As we well know, the Achilles heel of an SCR is its rather slow operation. So with a Dtscr, since the triggering is external, we can reduce the distance between the anode and the cathode to a minimum, and in that way we get a device which is considerably faster. The final advantage of a Dtscr is its higher failure current. This is mainly related to the fact that the diodes in the trigger chain act as a secondary ESD current path during the time when the SCR is not yet latched up, and in that way it has the Dtscr has a higher failure current. So to summarize, we've seen why we need SCRs, why we need Dtscrs, how they work, and what are their main advantages. Of course, what is shown here is just the basics. There are still many other tricks which need to be applied in order to really tailor the Dtscr to fit their particular application which we have in mind. For example, when it comes to IoT applications, then it is more important to have an ultra-low leakage. And if we, for example, instead consider RF or high-speed applications, then it's a lot more important to have ultra-low parasitic capacitance in the Dtscr. So thank you for following this video, and hope to see you in the next episodes of the series.